So I'll be talking today about agentic relevance tuning. We've all heard this from our management, right? Search is perfect. That's the standard thing we heard from our management. Actually, more likely, search sucks is the usual thing we hear. So what do we want to do? We want to improve relevance, typically. That's one of many things we want to do. We want to improve the UI, we want to improve data quality, but let's think about relevance for a moment. Everyone wants it. No one really knows how to achieve it. I mean, we all have our tricks, but we don't really have a plan for doing it once and done. You say, okay, I'm going to spend a week and I will have relevance, have perfect relevance. It's actually a lot of work, and it's ongoing work. And it's ongoing work partly because the corpus changes, our business strategy may change, the customer mix may change, all sorts of things can change. The season may change. And more specifically, we have problems where people come up to us or come up to our CTO or our CEO or our salespeople and they say, no one can find iPhones on the site. And of course, you investigate, why can't they find iPhones? Is it because they're listed under some other brand? Is it because they find iPhone accessories? Whatever. Revenue is down. And then, of course, we have our very helpful senior management, which comes and says, where are you guys? Everything is solved now with AI. Just use AI and you're all done. Well, we know that that's not true. What we do know is that to improve search, we have a process. It really is a process over time. This is the same slide I've been presenting for the past 5 years, so if you've been here before, you've seen it before. But sadly, it's still true. And there are 3 parts to this cycle, what I call the virtuous circle of search improvement. You have search processing, which is how you generate results. You have measurement analysis, where you see what sort of feedback you're getting on the results. And then you have tuning, where you take the feedback and adjust the system somehow, maybe by adjusting it, the parameters, maybe by doing post-processing, something, and then of course you go back and say, well, that wasn't perfect, let's try again. So that's search processing is things like lexical search, semantic search, sparse neural search. There's been a lot of progress in this area. A lot of progress. I mean, in the past, as you know, in the past 5 years, the whole embedding thing has exploded. Embeddings do amazing things for many queries, not all of them, but for many queries. We have improved the speed of ANN. We've improved the memory consumption. I mean, I'm just talking on OpenSearch. The other engines are doing similar things. We've improved caching strategies. We are using GPUs to speed up calculations on vectors. At OpenSearch, we've also speeded up lexical search, and I think some of this comes from Lucene, so many other Lucene-based engines are also benefiting from faster lexical search. We and many others have introduced sparse neural search, SPLADE-type algorithms. And then there's LLM-based algorithms like query understanding and rewriting, and result synthesis like RAG. Actually, RAG is sort of ambiguous in this diagram where it belongs, but that's okay, it doesn't matter. Next stage is the measurement analysis. Here we've made some progress. So at OpenSearch, we've released user behavior insights, which is a standard way of collecting data about what users are doing. It's not that people weren't collecting data before. We don't claim that this is hugely innovative, but what is innovative is that it's a single standard that you can use for everything, for search results, and designed specifically for search results, unlike systems that collect data for other reasons like page flow and things like this. OpenSearch Connections has had Quepid for some years. Very nice little system. OpenSearch Search Relevance Workshop we announced this year, and it's out in OpenSearch 3.1, which is out any day now. So we've made some progress in measurement analysis. But in search tuning, we haven't made much progress. You say, oh, well, how about learning to rank and semantic re-ranking? Well, those are great, but they don't really address recall. Those are post-processing. So if you're getting bad results on the first round, you're going to get bad results on the second round, which I like to call garbage in, re-ranked garbage out. So I'm sure you've seen this phenomenon, and one of the interesting things that we've learned, both at customers and some academic studies that have been done, is you can't solve that just by retrieving more things on the first round. In fact, that can be counterproductive in many cases. I can point you to the studies some other time, but that doesn't address recall. And so we're left with these manual tricks like field boosts and various lexical things like phrase boosts, and then hybrid search. We can somehow combine neural and lexical techniques, get better results. All of this is really in the realm of, you might call it alchemy, or my favorite term is numerology. Numerology is math that actually isn't based on theory. It's math that sort of works. Say, well, let's average this and that, and we'll get a better result. That's numerology. Numerology is also when you say your birthday was the 23rd of December, therefore you will be very good at geometry, this sort of thing. And so we're stuck with the classic technique of the very skilled finger, and some of us have better fingers than others, but it's not really a systematic technique for improving search. So what is the manual process we go through? I'm going a little faster than I expected, so you'll have plenty of time.
Yeah.
So what is the manual process that we currently use for doing this systematically, for improving search systematically? Well, first we identify a problem. So identifying a problem can come from various sources. It can come from talking to users. It can come from looking at our logs. And the iPhone example is a sort of standard example where people search for iPhones and they get iPhone accessories. Very classic example. I think all of you probably have ideas about how to fix that. So that's the second step of generating a hypothesis of maybe if we use technique X, like weighting results by sales figures or something like this, or popularity, however you measure that. So there are various techniques we might use, but we're not sure that that's going to work, right? In this case, we're pretty sure that that's going to work, but in other cases, we have an idea of how to improve search, but we don't really know if it's going to work. Like if we do phrase boosting of various kinds, or do we need to use mutual information to choose significant phrases to boost, or maybe just shingling everything is fine. Who knows? What's better and what's more efficient? We're not going to talk much about efficiency today, but that's another kind of thing that you can apply this approach we're doing to. So you generate hypotheses, and then you generate what we call search configurations. So search configuration is just the notion of a black box that takes queries and produces results. That's all it is. And in our Search Relevance Workbench is a pretty basic concept where you have configuration A, configuration B, and want to compare the two. And Search Relevance Workbench is designed for manual comparison. You can derive statistics like NDCG, where you get a single number out of the comparison. You can do eyeballing, which I presented at another conference, which is something we all do, but I think we don't admit we do it, or we don't talk about doing it, which is you look at the search results and say, what happened in this case? Let me try my favorite query, which is red iPhone. So I put in red iPhone, and I look at the results from algorithm A and algorithm B, and sometimes they turn out to be identical, so I wasted my time. And sometimes they turn out to be different, and I said, well, are these better or worse? And I look at them and say, oh, I see what's going on here. They're random, it turns out, because every time you re-index, you get a different doc ID, and the result depends on doc ID or something crazy like this. So we have a systematic way in Search Relevance Workbench of comparing results across hundreds or thousands of queries where you can look for the most different results, which is what we try to do manually but don't have the tools for normally. So you look at the most different results, and then you just look at them and you say, all right, I see we're doing a better job on color, but we're not doing a great job on size. If I say I want a large iPhone, does it actually understand that model 17 is larger than model 16 or whatever? All right, so anyway, we generate these hypotheses. We generate these search configurations, A and B, where you're going to run some offline tests, which is what I just talked about. You look at the results offline in your test environment. And then ideally, you run online tests, excuse me. So online A/B tests, what you do, you choose people with odd birthdays and people with even birthdays or whatever, and half of them get algorithm A and half of them get algorithm B. Sadly, it typically takes months to get statistically significant results from these A/B tests if you're doing that kind of A/B test, population A, population B. I mean, how many of you have had experience with A/B tests that take forever to get to significance. Okay, sounds like a familiar problem. And then eventually you say, okay, this is enough. I'm comfortable with it. It looks like it's doing better. My statistician isn't happy, but whatever. I'll just put it into production. So you're iterating on a scale of months. This means that each test you do is taking months. So if you want to do 6 or 10 or 20 tests, you can do parallel tests sometimes, which requires a lot more discipline, requires hiring more data scientists probably. But it's hard to do also from the system's point of view. Can we do better? Obviously, I wouldn't be here if I said no. So the answer is yes. I mean, this is actually a pretty well-defined procedure. Not a perfectly well-defined procedure. I might not want to write Python code to do this because it's a little brittle around the edges. We might want something that's a little bit more flexible than an algorithmic approach. And anyway, agents are in fashion, so we have to use agents. Right? So what does this mean in practice? We have the various processes identifying a problem. We can build up a library of business cases. Some of them the LLMs already know about. You don't need to do much work. Some of them we can tell the LLM, well, here's actually, let's look at this. Here's some, well, no, this is the second, that's the next step. So that we have these various problems that we might identify. Another kind of problem, what's another problem that you might identify? That we're selling things that are out of stock. Or we're displaying things that are out of stock. Not a good experience. So we have a library of these business cases, and you'd like to use evidence both from the user and from observing behavior about which of these is happening. Next thing you want is a proposed fix. You say, I think that shingling is going to fix this problem. Great. Well, we had a meeting a couple of weeks ago. We came up with about 40 just by chatting, and I'm sure there are 40 more of approaches to try. And again, you're not going to go through these systematic. You're not going to go through 1 through 40. That would be silly. You want to somehow rank them about which one is most plausible as a solution for this particular problem. Now, plausible is a funny word, right? So it requires some judgment. It requires maybe some randomness. Again, I'm not comfortable writing that as code. Then you want to create these search configurations, which is a sort of annoying process where you take an existing query and modify it, typically. That's the most typical case. There are other cases, too. You might want to re-index in some way if you're using a different lemmatization algorithm or whatever. But you have these search configurations. You have to set up these search configurations, which will probably take a few days of engineering effort, and then a few more days to QA it and so on. So it's going to be a little painful. Then you can run some offline tests, like the ones we talked about. So in the automatic system, this is being done by the system for you, both rewriting the queries and running the offline tests. Then it comes back to you and says, hey, it looks pretty good. And then you run, oh, here's this magic word, interleaved A/B test with real-time feedback. So I'm going to talk a little bit about interleaved A/B tests. How many people have learned about interleaved A/B testing? Okay, not a lot, so it's worth going into a little bit of detail. The bottom line here is that using a combination of agents to run the process rather than human engineers and interleaved A/B testing, you can start getting a cycle time that's measured in days instead of in months. And so these are various approaches. So let's talk a little bit about interleaved A/B testing, which is one of the two major techniques being used in the system. Our friends at Otto, I think it was in spring at Mices, gave a presentation where they showed how effective this technique was. So what's going on here? In a classic A/B test, you take the odd birthday people and the even birthday people. They're probably not issuing the same queries. So how do you perform a statistically reliable test of which engine is doing better? Well, you can say, yeah, okay, the rank of the result is a little higher in this case or lower in that case, but you would really like them to issue the same queries. Unfortunately, you can't force people to give the same queries. That would be problematic. So with the different queries, you get very slow statistical significance. This is where this phenomenon of waiting for months for statistical significance comes from, because you're comparing results not from the same user, not the same query, And users vary too, right? So it's not just the queries. So interleaved A/B testing shows each user both A results and B results. You say, how's that possible? Well, it's pretty simple. You interleave them A, B, A, B, A, B. So wait a second, what if there's some duplicates in there? Well, there's some lovely algorithmic magic. There are several different algorithms for doing this, and there are various tricks and various traps you can fall into in doing this. But fortunately, people who have actually spent years looking at this have come up with several good approaches. And we've chosen one of them. It happens to have a bizarre name from my perspective. It's called
Team draft interleaving?
Team draft interleaving, yeah, which I'm not a sports person. Turns out this is a term from the way US commercial sports teams choose teams from college students. Not my thing. But there are a bunch of algorithms for doing this, and that's one of them. And so you can choose these results and get rid of the duplicates and then see what's clicked on. And with, again, some magic math, you can determine which of these each user is preferring. This gives you much, much faster statistical significance. Our friends at Auto went from, again, from months to days. I think it was 2 days was their typical cycle time. Is that right, Renee? I think it was 2 days, wasn't it? You don't remember? Ah, approximately right. So what's the other half of the magic? The other half of the magic is using agents to run the process. So we have a variety of kinds of agents. We have an orchestration agent, as usual. So, is everyone familiar with what we mean by agents in this context? Who does not know? Well, I won't embarrass people. Who does know what we're talking about when we're talking about agents? Oh, okay. So it's worth actually giving a little bit of introduction there. So it turns out that these LLMs that we all ask these amazing questions to, like, what is team draft interleaving? And it says, oh, it's from American sports, blah, blah, blah. Great questions. It turns out you can also ask them things like, if I want to plant potatoes, what should I do? And it says, oh, well, first you need to plow your field, then you need to use this, then you need to do that, then you should probably mix in some compost, and then you should plant them between January and March if you're in Berlin, and so on. So it can actually give you a sequence of things to do. You say, well, that's not very good. What am I going to do with that? Well, it turns out you can have it do that in such a way that it's interpretable as a programmed process. So you're essentially using the LLM to run a process for you. And if you give it the right prompt, that is the right instructions, this can be very, very effective. So that's what we mean by agents. We mean essentially LLMs being used to do things rather than just to answer questions. And now, one little technical point is agents are the part that are programmed with LLMs, and then agents can call tools, because agents can't actually operate on the world. You can't tell ChatGPT, I don't know, call the elevator. How can ChatGPT call the elevator? So you have these things that are called tools, which are typically pieces of code that says, oh, I know where the elevator interface is. I'm going to call the elevator and call the elevator, or give you a Coca-Cola. That's the classic 1960s agent application, and charge you for your Coca-Cola. So that's a tool. I like to talk about modules to not decide in advance whether a given function is going to be performed by a tool or by an agent. Is it going to be a piece of code, or is it going to be an agent? It could be either in some cases. In other cases, it has to be a tool, because the agent can't call the elevator. And now, Daniel's going to run through how this actually works.
Thank you for that introduction, Stavros. So we are kind of envisioning this agentic relevance tuning as, a combination of a bunch of things. So what we do think is that there still will be some kind of human interaction. And this diagram here is by no means a complete diagram. So, I still encourage you to take pictures, but don't tell anyone that we think that this is all you need to do agentic relevance tuning.
Oh, maybe one other thing I should add, which is this is a project at its very beginning. So we do not have results from this project yet. We have begun working on it starting 2 weeks ago. So we expect to have results probably next year. But this is quite seriously, and we'd love to have your feedback, but this is where we are today.
And the part where you can give us feedback will come at the end of this talk, actually, and not only by asking questions. So, but without going too much into detail what's coming, how are we envisioning this? So we still think that, especially in the beginning of this process, there will be human interaction. And the human interaction will be starting with, for example, formulating a kind of problem or a complaint. And the agent orchestrator will then take this complaint and then try to identify some of these hypotheses that Stavros talked about. So if we start with a very simple problem users may have, it's like, I'm searching for X, but I'm not finding Y. So I'm searching for iPhone, but I'm only finding iPhone cases, for example. I'm not finding the real iPhones. Or I'm searching for iPhone cases, and I'm finding a lot of iPhones, but no iPhone cases. So this may sound trivial, but this can eat up a search team's time, right? So we are trying to identify an automated way how an agentic system can prioritize certain things to actually fix, or rather disregard and discard from a backlog. So when this request comes in, the agent orchestrator realizes, okay, I need to find out several ways how I can fix this problem. So the agent orchestrator calls the hypothesis generator and says, hey, here is a problem. How do you think we can actually go about and fix this? So the hypothesis generator has let's say, connection to a knowledge base somehow, and this is now this vast majority or vast collection of different techniques and methods that we can apply, like relaxing a query, applying synonyms, creating rewriting rules, train an LTR model, whatever. So there are at least probably 100 things you can do to a query, and we don't want to think about each very simple problem to identify the best method to apply. We want an automated process. So the agent hypothesis generator may get back and say, hey, I think you should try and relax the query because you got 0 results, and by relaxing the query you can improve your recall and actually surface results. So it may formulate a hypothesis like, I believe that introducing query relaxation will result in finding the actual document you're looking for. My internal check shows improved recall. My internal check is now a quite important piece because the agent can now, by itself, already reformulate the query, do a test lookup, surface, hey, does this change actually result in this improvement the user is looking for? And then it can already get back to the user with a qualified answer. So it's not like I try one thing, I do that successfully, and that's the thing that I will report back. We rather think of it like there are 10 things to do for a recall-oriented problem, and the agent can already try out several of these and then get back with a better answer than, here are 10 things you can try out. But I actually tried this and that, and this was successful, and this maybe wasn't. So this internal check, I think, is a pretty important thing.
Also known as the offline evaluation.
We'll get to that in a second here. So the user can then say, okay, sounds reasonable. So this is a fancy way, or a fancy way of putting that would be, that's a human in the loop, right? So the agent doesn't do everything autonomously, but the agent reports back to the user and says, hey, relaxing the query may be an option to go for, and the user confirms, yes, okay, please, let's try that. Next step now is offline evaluation. So the first check is rather a very quick, simple offline check done by the agent, the hypothesis generator, saying, hey, I think this actually fixes your problem. Now we go into offline evaluation. Offline evaluation is now a larger scale test. So now we are not looking at one query, we are maybe looking at 50 queries, 200 queries, 2,000 queries, and we want to measure how much change do we introduce when we go from not relaxing the query to relaxing the query, from search configuration A, what's currently in production, to search configuration B, that now has this proposed change implemented. For this, we now need a different set of tools. So we need, for example, a query set generator. We need these 2,000 queries, or how many queries ever we want to test that on. And large language models can help us. They can either retrieve maybe similar queries from user behavior insights data or other behavioral data sources, or they can generate queries themselves because, well, large language models do know quite something about language, and queries are often language, so they can be used for tasks like these. We maybe need something like LLM as a judge as a tool, because to calculate search metrics, we need judgments, and search metrics are actually quite important to know, does our search quality improve, does it decrease, and to calculate search metrics, we need judgments. We may also have something like an implicit judgment calculator in our set of tools that tries to calculate judgments on behavioral data, but having that flexibility, I think, will also be key in that. A search configuration tool is then something that can generate maybe different variants of this first idea. So maybe how to relax the query is something that's not very narrowly defined in this first hypothesis generation step, but maybe it's something like minimum should match rules, 10 of a kind that this agent offline evaluator tries out. So there's a lot of variance in here still, and this offline evaluation step is a very important one in relevance tuning in general, and even more so in this agentic world, because we really need to make sure what we introduce in the online world, which is the next step, as soon as the agent orchestrator reports back, hey, I tried this out on this and that query set with these judgments, and your search metrics are actually showing the following improvements. So NDCG goes up by 10%, DCG goes up by whatever. So reporting back what happens in this offline evaluation step so that the user can then actively decide, yes, this sounds great, please run an A/B test for this search configuration. And now we're entering a world where we are also pretty early in the process, because now we're kind of, well, we need to give an agent access to your online world, to production, right? Because the agent now has to run an A/B test. How do we do that? So this is something that is not there already, yeah, but this will be part of the collaboration between OpenSource Connections and the OpenSearch project team, that we figure out ways how we can introduce interleaved A/B testing in, for example, a search pipeline, so that it becomes, I don't want to say effortless, but at least for query time changes, easy to apply these in the online world, so that then an online testing agent can run these and then again report back to the user after a specific time. Hey, I ran this test now for 38 hours, and your KPIs improved significantly, or they didn't improve.
Right. Let me add something here, which I think is an important point that Daniel made, which he didn't emphasize quite as much as I would, which is that interleaved A/B testing has been around for a while. It's been around for at least 10 years, I think, maybe more. But many people, very few people are using it. And one of the reasons, my hypothesis about why people aren't using it is because it's a pain. It's a pain at various levels. You have to run different configurations. You have to manage them. You have to do the systems work to integrate the results into an A/B result. You have to report on those results so you can analyze them. You've done this, it seems. So do you agree it's a pain? Okay. So if you can have a magic wand to say, I want to do interleaved A/B testing, would you use it? That's the wrong answer. I'm not sure it's the wrong answer.
There's one option, just to give you a nudge in the right direction here.
What are you doing for dinner? So I think an important point here is that a lot of what we're doing here is not difficult in the sense that we don't know how to do it. It's that it's a pain to do, and it takes time. And the agentic approach here with the interleaved A/B testing has it out of the box so that everyone can use these advanced techniques. You don't have to be an advanced data scientist to use the techniques.
We do realize that, I mean, you mentioned magic box or magic wand, yeah, several times right now. It does sound magical, and as of now, thinking of it is pretty magical, yeah, but that's the early days that we are in right now. And it becomes even more magical if you think about, okay, this sounds great, and now I want to push that to production. So this is now something that isn't running in a test scenario, but now this is actual live deployment. So the agent needs even more power to influence and impact your live system. This is now, let's call it one happy path that we have seen. Right, so maybe it's a pretty easy, straightforward challenge that the user came up with, so not finding X for the query Y. We do believe that there are probably more unhappy paths than happy paths. So exploring these will definitely be one of the, let's say, key challenges that we will have to work on. And also all of these, like, technical challenges that we already are seeing under the surface. So rebuilding an index, for example, with shingles or n-grams, rebuilding an index with, well, whatever change we envision, or thinking about more complex recommendations like, hey, you should try re-ranking with a learning-to-rank model. How do I instruct an agent to actually train an LTR model? I would doubt that we are...
We have an answer for that.
We have an answer for that?
Follow-on contract.
Well, yeah, so we... So we don't assume that we will solve all of these within the next couple of months. But what we want to do is at least release us as search relevance engineers or consultants from the drudgery work. Yeah? So the easy fixes and prioritizing the easy fixes maybe are the ones that we believe agents are perfectly capable of. Not now, but hopefully in a couple of months. And that is definitely what we will be trying to solve in the course of this project. So to stay on the happy path, I haven't prepared an unhappy path, and we'll pass it back to Stavros to take us through the conclusion.
So, engineering point of view, product manager point of view. From a product management point of view, I want to make sure that we start with something that works, end-to-end works. And so this is in our engineering plan, is to make sure that we can do simple things easily. So this may sound ridiculously ambitious. Well, it is ridiculously ambitious in the general case, but we're convinced that we can do the end-to-end happy path for some of the simple cases. I mean, take the classic cases like field boosting. I think we've all played with field boosting. You try something, you let it run. You try something else, you let it run. You try some test cases offline, and so on. I think we can. I'm quite convinced that we will get field boosting right on this within the time we've given ourselves. Will we be able to get something like, let's say, something that requires rebuilding the index right? Probably, if it's fairly simple. Will we be able to take some existing complex query that you've built over the past 5 years and it is 10 pages long and understand that query well enough to be able to modify it? There, I begin to have my doubts. And I think we both have our doubts that we wonder, okay, how far can you go? And I think we'll only find out what the limits are by trying to do it. So we're not trying to do a theoretical thing. We're actually going to build this thing. And you know, I've been surprised by what LLMs can do. With zero instruction about the OpenSearch query language, I've asked it to do some fairly complex things. I do this in the OpenSearch query language, and it'll generate some code, and I'll put it into the system, and it'll give me a syntax error. So, okay. I go back and say, I got this syntax error on this code. It says, oh, of course, you're absolutely right. You're brilliant. You know how the LLMs talk to you. You're brilliant. Of course it's an error. I'm terribly sorry. Let me fix it for you. And I'll fix it. And some of the time it actually fixes it correctly, even in fairly complicated cases. So we will see how broadly this works. I don't know. We don't know, because we're at the beginning of the project. But the ambition is to do exactly what's on the screen. That by combining the power of agents with the power of interleaved testing, we'll get a much faster feedback loop in improving relevance. So fast, goal-driven relevance improvements. Now the QR code there is for a little survey that we have on what you might like out of this project. So please go ahead and take out your cameras and give us some answers. It's not very complicated. So I think it's 5 questions. Like, I'm in the way. Well, I should have my QR code on my forehead. All right. So I think that's it for today. Questions, please.
Thank you, Daniel and Stavros. Do you have any questions?
Well, Charlie has a question. And
Yes.
be kind.
Firstly, thank you for setting us on a path to automate us relevance engineers out of work. But as an attempt to throw a spanner into that particular machine, when you're dealing with a particular problem and you have a set of queries that illustrate that problem, and you put together an offline test around that, and you come up with a solution, that's great, and that fixes those particular queries, makes it better for those particular queries. But then you often end up with interactions between your new fix and some other fix. You relax the queries, that breaks lots of other things over here.
Absolutely.
What ideas do you have about testing for those kind of conflicts between two great ideas that just don't work together?
Well, two answers to that. First of all, so far we're doing this strictly serially. We're doing one fix at a time, which may break previous fixes, no question. So can that be improved on? No doubt. Secondly, I think perhaps we ran a little bit too quickly over the offline testing. The offline testing isn't just for my examples of where things went wrong, but you also want to do some sort of regression test and take your a few thousand queries, run it through. And again, some of the evaluation can be done completely automatically. And DCG and so on are fine techniques, especially if you're using LLM as a judge. Is it a perfect judge? No. But is it a useful judge? Probably. And then I, unlike perhaps some of the members of the team, believe a little bit more in the eyeballing step, where you actually look at the results and say, okay, boss, you did this improvement, and here are the queries where the results are most different. Tell me if these look good or bad. Even if the NDCG is better, there may be some cases which are extreme. So I believe a lot in the power of us search engineers. So I don't think we'll be put out of, or former search engineer, but I don't think the search engineers are going to be put out of a job. I think you'll be given power tools for doing your job more effectively.
Thank you. A question from the online audience, interesting one. How big is the project team, and what areas are you expecting to invest the most time?
You know, we are fairly secretive about money and heads at AWS, so I'm not going to tell you the exact number of heads, but it's you can count them on your hand. And we have experts who have deep experience with search relevance, who have the gut feeling of what works and what doesn't. So we expect to be quite productive in this. And again, the agentic part takes us out of the business of writing hundreds of pages of Python code. We expect and hope that will speed up our development as well as your development. Next question.
I'm curious, at least for me, for our use cases, my company, it looks like for this really cool idea and also really important problem to be solved, it looks to me that it's even bit too big. I think if you solve part of this problem, it can be viable already, and it can bring some value.
Exactly, I agree completely. I mean, I think we mentioned this, that we think that there are some cases that are low-hanging fruit that we are quite confident that we will solve without much problem. There are other problems where it's more complicated if we're, let's say, re-indexing DUI, and we have we have to have two different systems. If you can't do it all on one system just by using a different query on the same system, that will add some complexity at one level. If you have, as I said before, an existing very large query, that will add complexity, which I don't think we'll be able to deal with at a first version, and so on. So, but I agree with you completely. The hope is that we will address some problems in the first round that will immediately have impact for you, and then over time, if that shows itself to be viable, then we'll invest more effort into the more difficult cases.
First of all, great talk, guys. I'm expecting big things. My question here is...
I'm sorry, bad tactic. I'm supposed to set expectations low. Right?
Oh, it didn't work. Sorry. Anyway, my question is, so just to give a little bit of context, when you ask about interleaving testing, for example, my main issue with this is that it's difficult to manage integrations with technologies that actually do A/B testing, for example. So my company uses some form of some Google tooling for this. Obviously, my engine doesn't. So my question is, do you plan any kind of integrations that go beyond OpenSearch for stuff like this? Maybe some re-rankings, additional. Search engines rarely just go to OpenSearch. And
sure. Great question. Again, we'll start with the simple case. We'll start actually with the very, very simple case where it's not only OpenSearch, but one instance of OpenSearch, where you have just different query patterns on the same instance of OpenSearch. That's probably the easiest to start with. And then we'll extend it further. Now, we've already done integrations with other systems. With our Search Relevance Workbench, we have interfaces to other systems, so we can call other systems and so on. Can we change their queries? We haven't done that. Can we do pre- and post-processors? Well, there, actually, the answer is this notion of search configuration includes the idea of pre- and post-processors. However, it doesn't include the idea of fiddling with the configuration. So that will present a challenge if we have to fiddle with a more complicated configuration with outside components and so on. Every time you have an external dependency, and we have an internal document where which we'll be publishing, which talks about the different techniques and whether they have external dependencies. I mean, even as trivial a thing as two different synonym files. That's just a pain to manage, right? Daniel, do you want to add anything?
I mean, the bottom line is we talked about this project for 2 days intensively, and I think we found more challenges than solutions to begin with. And that's why I think it's a good way to start small and then grow, because trying to solve everything in this first step will not be possible, because we will just go from dependency to dependency to dependency. So yeah, it's no good answer maybe to your question. We'll start with OpenSearch and very tightly, very narrowly, and then try to expand that.
And I'm a big believer in getting an end-to-end solution, even a very simple end-to-end solution, rather than solving one narrow problem at a time.
Yeah. Okay, we have one question that got quite a number of upvotes online. In this agentic tuning setting, do you plan to use agents to simulate users in the interleaving testing? If that's the case, how do you plan to achieve it?
No.
Okay. Got another upvote. So, okay. All right, so we're at time. Daniel and Stavros will be around. So let's give it another round of applause to our speakers.
Thank you.